The bridge in this problem is 28 meters above the ground. There's a boy standing on the bridge, and he throws a rock straight up in the air. It goes up and comes back down to where it's going to hit the ground later. The initial speed is v0, and we're told that it takes 6 seconds for the rock to get back to the height from which the boy threw it. Then we're asked to find the speed v that the rock hits the ground with. The first thing we'll find in solving this problem is the rock's initial velocity v0. We can find that using this kinematic equation. Let's look at the motion from the time when the rock is first thrown to when it returns to the same height. That means that delta y is 0. There's no displacement or change in position over those 6 seconds. We can solve this equation for the initial velocity v0, canceling one of the times t to find that it equals 1/2 g times t. Substitute the numbers and calculate to find the rock's initial velocity is 29.4 meters per second. That's how fast the boy threw it, straight up in the air. Now we can use the time-independent kinematic equation to find the rock's speed as it hits the ground. That equation is here. And we can substitute all the known values. The initial velocity is the number we just calculated, minus 2g times delta y, the change in height from the beginning to the ending of the motion. That's minus 28 meters because the rock was moving down. When you calculate, you get 1413 meters squared per square second. The rock's speed as it hits the ground is the square root of this value. That gives you 37.6 meters per second.